Electronics for all.
Be warning. This video for scientific only. Be careful if you try to do it at home. A simple 555 timer-based buck regulator for DC motor speed control. In this article, we will make a buck converter using 555 timer IC and a IRFZ44N N-channel MOSFET and use it as LED dimmer circuit. This circuit is basically a simple power electronics DC to DC buck converter which can be used to step down voltage. Its efficiency results in better battery life due to reduced heat generation, making it a lucrative option for smaller gadgets. I have designed a converter circuit using Circuit Wizard and fabricated a simple in-house PCB and tested the module with the LED strip. How is a buck converter different from a linear voltage regulator and why is it more efficient? Both the buck converters and linear regulators are step-down converters. In other words, the output voltage is lower than the input voltage. The buck converters employ PWM switching technique to step down the voltage, whereas the linear regulator acts as a variable resistor, constantly maintaining the voltage divider network in order to maintain constant output. But the downside is that they waste the energy in the form of heat to maintain the output. Since a buck converter utilizes PWM, pulse width modulation signal, to maintain the voltage, theoretically it is a 100% efficient system. But in real life these buck converters can be 90 up to 95% efficient, whereas the linear voltage regulator is extremely inefficient, depending on the input and output voltages. So, if you are designing a small battery-operated system, a buck converter makes more sense due to its higher efficiency. How does a buck converter work? A simple buck converter works by simply opening and closing the switch in a predefined time period, also known as duty cycle, to maintain the required output voltage. The figure shown below shows a simple buck converter topology which has following components: a voltage source for supplying the input voltage, a switch for maintaining the duty cycle, an inductor to reduce change to the output load, a capacitor to smoothen out the output, and a diode connected in parallel to protect the switch, which is generally a transistor, from reverse voltage. We can get any output voltage between 0 and input voltage by changing the duty cycle. In order to make the system work in real-world application, we need to switch on and off the switch a lot faster than a human can perform. Therefore, we use a PWM pulse generator and a transistor as a switch to perform the task. A 555 timer IC in astable mode can be used to generate the PWM output for our operation. The IC 555 generates around 30 kHz frequency with the help of passive and active components connected to it. The circuit uses the 555 IC as the PWM generator, and hence the whole circuit is based around the same. Buck converters are used in a lot of applications where efficiency is paramount. Some applications includes battery chargers, power amplifiers, quadcopters, powertrain and battery chargers of EVs, medical application, smartphones, laptops, and are also used in motor controllers, and more. A 555 IC-based converter is one of the simplest, yet efficient method to keep the complexity as well as the cost of your project low while achieving a high efficiency and improving lifespan of your components. This easy power electronics circuit can step down a DC voltage with efficiency as high as 95% compared to 40 up to 60% efficiency of a linear voltage regulators. This driving technique is also useful for the speed control of a motor and dimming LEDs without affecting its lifespan, making it a very versatile voltage control option for electronics project. Follow us on all social media. If you enjoyed this video, please like it, subscribe, and click the bell icon to get new video updates.